Good morning everyone. Now let us see the statement of Bayes theorem. So now in the last video we know the definition of a conditional probability. We know the definition of conditional probability is an event A is said to be conditional probability. It means the event B is already happened. So it means that the happened event we are going to write in the denominator that we observed in the last video. Now let us see the statement of Bayes theorem is if E1, E2 and so on n are n mutually disjoint events, okay, such that P of A is not equals to 0, then for any arbitrary event A is subset of union I is equals to 1 to n E and P of A greater than 0. Then we are going to prove that P of EI given A is equals to P of EI into P of A given EI by summation I from 1 to n P of EI into P of A given EI. This is what we are going to prove. Now let us see how to prove this statement. So in the given statement they mentioned clearly what is that given A is a subset of union I is equals to 1 to n EI. So if anything is subset, then we are going to write it as now A intersection of union I is equals to 1 to n EI. A intersection union I is equals to 1 to n EI. So now let us see here what is the value. I will go with some example which is having the elements. In the given statement it contains E1, E2 and so on, En or n events. So now let us see here. I am going with a small example. Let us take with the set of elements E1 is 1, 2 and the set E2 is having the elements of 3, 4 and E3 is having the elements of 5, 6. We consider the n sets are 3 sets in the given theorem statement. Now what we are going to define here, union I is equals to 1, 2, 3 EI is equals to 1, 2, 3, 4, 5, 6, right? So now what mentioned here in the statement, A is a subset of union I is equals to 1 to n EI. So A is subset means can I take whatever the element of A in the events A is equals to, suppose if I am taking A is 1, 2. So what happened here now, A intersection union I is equals to 1 to n EI. What is A set now? We take here it is 1, 2 intersection of what is EI sets now 1, 2, 3, 4, 5, 6. This is equals to what is the set now 1, 2. What is the intersection set? This is equals to set A only, right? So now let us see here A intersection union I is equals to 1 to n EI is equals to A only as per the example. Okay, so now apply probabilities on both sides. What happened here? Probability of A intersection union I is equals to 1 to n EI is equals to A. Okay, probability of, so the same thing we know axioms of probability, 3 axioms of probability. What are the 3 axioms of probability? I am reminding one more time. P of A is greater than or equals to 0. Sum of all the probabilities is equals to 1. And the third is if A and B are 2 disjoint sets, then P of A union B is equals to P of A plus P of B. So now we are going to write it as union set. So it means like that P of union I is equals to 1 to n A intersection EI is equals to P of A. So before the concepts we learned De Morgan's laws. So now let us see one more time by De Morgan's law. What is De Morgan's law here actually? So this is what P of A intersection of B intersection C. If you are having 3 events, so how to write the 3 events now? P of A intersection B which is having the elements of union of the 2 elements, union of A intersection C. Or you are going to like in this way or not? Whenever you are having 2 events now. If you are having 2 events now, A intersection E1 union A intersection E2. The same thing, the way what we are going to write it as now, union I is equals to 1 to 2 because we are going to write 2 events, right? So this is equals to what? P of A intersection EI. So the same thing now we are going to write it as probability of union I from 1 to n A intersection EI is equals to P of A. because here in the given statement we are taking E1, E2 and so on, En or n mutually disjoint events in the given statement, right? So now let us see here P of union I from 1 to n A intersection A. We know the third axiom of the probability. What is the third axiom of the probability? Now let us see by third axiom of probability. By third axiom of probability, what happened here? This is equals to probability of union I is equals to 1 to n AI is equals to sum of all the probabilities, right? So this is equals to what? Summation I from 1 to n P of A. Okay. So the same thing we are going to write it as summation of P of, how to write this is A intersection EI. P of A intersection EI is equals to P of A. And we know the conditional probability definition. The event which is already happened, we are going to write it as in the denominator, right? So now let us see here by conditional probability. How to write here by conditional probability? Summation of P of EI into P of A given EI. P of A given EI is equals to P of A. Let us see here, it is an equation 1. It means that how to write this equation? The event A is already happened. The event which A is already happened. So now let us see the exact definition of conditional probability. How to write here? By definition of conditional probability. By definition of conditional probability. How to write here now? P of A intersection EI. Okay. P of A intersection EI is equals to, how to write? P of EI into P of A given EI. Let us see this as equation 2. So without any confusion, I would like to continue in the same page. Now let us see here, you are going to write equation 1 and 2. The same equation 2, how to write again? Here you are going to write the event A is already happened. The same statement you are going to write the event A is also already happened, right? So now how to define this? P of A intersection EI is equals to P of A into P of EI given A. What happened here? The same thing you are writing. The second statement you are going to write the event A is already happened. The same definition you are going to write the event A is already happened. Okay. So what we are going to prove now? P of EI given A is equals to, what is P of EI given A is equals to? From this, how to write P of EI given A? P of A intersection EI by P of A. Okay, so now substituting the equations 1 and 2 in this statement. Okay, so what happened here? Let us just substitute 1 and 2 equations. Substitute 1 and 2 here. What happened here? P of EI given A is equals to P of A intersection EI is equals to, how to write P of A intersection EI? P of EI into, how to write P of EI into P of A given EI, right? So substitute in the equation 1 here, denominator, what is P of A? Summation of P of EI. Summation, how many elements? You are taking n elements. So you are going to write summation of P of EI into P of A given EI. Okay. So now the Bayes theorem is proved. Okay. So the problems are also in the same way. The given problem, it contains, you are having n elements. You have to identify first how many number of elements are there in the given problem. What is the success event are there in the given problem? The event is happened. It means the success event or the item is to be defective. You are going to finding out the element whatever we are having, and we count the conditional probabilities based on Bayes theorem.